Hi, today I want to show you how to render a ton of coins in real time, using techniques like particle billboarding and indirect GPU instancing. The video will also include some bonus visuals and tricks that I really wish I had found when I was learning Unity Engine earlier. Now, let's take a deep dive into this real-time rendering adventure of mine.
This project is one of those that start off as a duty, but eventually become a joy to work with. I like to have a moment to briefly run through the final outcome. Cool. And now, I'm happy to share something that I learned and experimented during the process. Basically, different ways to render a ton of objects using real-time graphic techniques. This will be a two-part video. The first part, I will show you this coin particle effect. And in the second one, we are going to take a dive into the gold mountain you see in this video, scratching some surface of indirect instancing. By the end of the series, I hope you will become a digital alchemist, basically who can grab any elements of you like out of thin air using those techniques. Before we start, quick walkthrough of some of the basic info here. This project is built in Unity URP, and we are going to touch some custom shader in this one. Don't worry if you're not familiar with shaders, as I will provide some links that went through the basics. For the ones ready, in our project, a lot of the code will be referencing the official URP lighting library, such as the fragment lighting function. This lighting function gives everything the same look as you can see here. It's essentially equivalent to the lid node of the shader graph. So don't get scared away by the HLSL file, as I will show you some implementation tricks that can help you easily write your own along the way. Cool, boring part finished. Let's dive into the first technique. I simply love the concept of a ton of coin bursting open through the container. When I first tackled this effect, I even started to look into GPU physics. Gladly I didn't fall into that rabbit hole. A lot of times, simple solutions are just better. Here, introducing particle billboarding with flipbook animation. I do argue that sometimes close-up billboarding can look really bad, but what makes coin a perfect candidate for this technique is that coins can be really energetic. The high-speed rotation and shimmering compensate for lower resolution and lighting imperfections. So, we need to do two things here. Make it rotate, and make its lighting to some extent at least resemble a gold coin in real life. We can always use the camera to render a billboard as a first step. I create a quick editor tool that can help with this. While taking a portrait of the coin, it can switch to different skins. The beetle skin is your standard pack. Move on, we will have this metallic roughness map, and all the way to a tangent normal skin as a prismatic option. These outcomes are rendered by a single unlit shader. We just need to sample the texture and make sure the utility ones are in linear color space. The only tricky part is we need to properly convert tangent normal to world space. Otherwise, just throwing a tangent map to your custom shader will make things look something like those. Here's a visual demo. The typical bluish colored normal lives in the tangent space, basically a flat plane with upward direction of the z vector, and that's why it looked predominantly blue. And as increasing bump scale, other channels kick in to add directionality. Here, it undergoes a tangent to world transformation to adapt the object's curvature in 3D. A flat tangent space normal will not affect the vertex normal, as everything is pointing completely outward. But if we increase the scale, the tangent vector will act as an additional layer of rotation of the vertex normal, giving objects extra detail. The detailed implementation can be found in URP surface input include file, in case you want to write your own surface shader. I'll leave a link and some of the other resources. Next up, I use another shader to hook up these intermediate textures, and use the lighting function I mentioned above. Of course, you can use shader graphs for this one. If observed from a certain angle, we will get a decent imposter, but just infinitely thin. Well, still not quite there. Well, since there's no depth data, the angle of incident is very different from that of a 3D object. But I think we can get away with it for now, if we're making a particle system. To make it rotate, I spin the coin 360 degrees along the y-axis while the camera is taking rapid captures. With the coin officially motion captured in all the passes, we are rewarded with these atlas stripes, ready to make flipbook. In Unity, setting up a particle system with flipbook animation is easy. Assign the animation textures, enable flipbook animation, and specify the dimension. And yeah, we got a working flipbook particle. And good news, there's almost zero extra work that needs to be done to use a custom shader for the Unity particle system. as Unity smartly modified the vertex streams and instanced them in one batch. Here is an example of the most basic shader you can write in URP. It is already working with the particle system out of the box. One trick I want to show you is, you can quickly add some custom vertex streams and just return a value on the fragment shader. And go to the vertex stream session and set custom data. The data has to be tightly packed. That's why the first custom data is only using a ZW channel, as XY is taken by the UV. We'll be using a second dataset. Then you can feed the vertex stream directly from the editor, and you can customize them however you want. So stop using Unity default particle shader and start to write your own. Back to the topic, the lighting logic is almost the same as the one we rendered a single coin, and since the compatibility mentioned above, so we can use the same shader to render the flipbook animation. And there's only one thing left to do. If you pan around the editor, there's a problem. The normal of the coin will mess up if looked from different directions. If you think about it, the flipbook animation is essentially displaying a coin rotating at a specific angle. The issue is that world space normal are only correct at that view angle. To fix this, we rotate the pixel normal along the view direction. One way to do this is to multiply the normal with the camera view matrix. We can also rotate the normal by alignment vectors using quaternion. All of these deserve their own topic. We are not going to cover them right now, but feel free to refer the link below for the final version of code. Now, let's take a look at it from different directions and also use multiple point lights. One last thing. Watch out for overdraws while enjoying the free gold, as all particles are drawn in one batch. Although it's a good thing, one pixel will be drawn multiple times since there's no depth buffer to test against with, as this is double confirmed by the render doc. So do reasonably adjust the camera position and use the particle system smartly.
And there you have it. We've basically scratched the surface of what it can do. Hopefully you enjoyed your time and then pick up some useful techniques along the way. Stay tuned for the next chapter, and until then, happy rendering!